All right, so it says that Q is equal to A squared over B squared, where A is equal to 100 plus or minus 5, and B is equal to 20 plus or minus 2. Okay, so I want delta Q over Q. That's the setup for the equation. And now I need to think about what's happening on the other side. So first of all, I have A squared, I have B squared, and I also have the fact that they're being divided by each other. Okay, now the way that it would work in terms of the squaring, just the A squared by itself is like this. I would say delta A over A, but I would put a 2 in front of it. Because remember that essentially it's delta A over A plus delta A over A, right? Because you're multiplying A by itself. So that means it's going to show up twice and you're adding it, so I can just put the 2 in front of it. On the other side, for the B, it's going to be the same thing, and it's going to be addition. Even though this is division, I'm still going to be adding these because that's the rule. It doesn't matter whether you multiply or divide. You always add the fractional uncertainties. So since that guy is squared, it's going to be also delta B over B. So I'll take you to the next step, which is to just simply get all the numbers plugged in, and then I'm going to leave it there, and I'll let you guys finish it. So delta Q, which is over 100 squared divided by 20 squared. That's the answer to the calculation Q, right? It's right up here. Okay, and then that is going to be equal to 2 times 5 over 100 plus 2 times 2 over 20. Okay, so what I would really like to see is that people can, from at least if you get to this point, that you could take care of the math, but there's still plenty of room for you to make math mistakes. I would recommend get the right side done. So on the next line down, I write delta Q, I get whatever this is, whatever this calculation is, I put that down there, and on the right side, I do all of this stuff. So 5 divided by 100 is 0.05, times 2 is 0.1, 2 divided by 10 is 0.1, but times 2 gives me 0.2, 0.1 and 0.2 is 0.3. So I'd have delta Q over whatever this calculation is equal to 0.3. And then it's one last step, which is to move this stuff from the bottom, remember the answer to the calculation, over to the other side by multiplying, and then you're all done. If there's any quick questions, I'm going to start the next problem, but if there's any questions, just turn your mic on and let me know what you want to chat about while I get the next problem ready. Sorry, I lost the question. 11 and 12. All right, number 11. So one of the things, I feel like is very, kind of important when you're trying to solve these problems is write out the equation, especially for these, because these are not equations that are familiar to you. We will be covering these. All these are equations that we will be looking at, but obviously we have not looked at them yet. So for number 11, you're dealing with this guy, this monster. F is equal to mv squared over r, where you have the following measurements. So m is equal to 2.8 plus or minus 0.1. V is equal to 14 plus or minus 2. And R equals 8.0 plus or minus 0.2. All right. This time I'm going to just set up the calculation. I'm not going to do any simplification. I'm going to let you guys do the cleaning up entirely on your own. All right, so first of all, we have nothing but multiplication or division. Okay, there's no addition or subtraction, so that means that we have to go to the multiplication division rule, which says add up all the fractional uncertainties of all these different pieces for the m, the v squared, and for the r. So the calculation will look like this. Delta f over f is equal to delta m over m plus 2 times delta v over v, that's because of the squaring, plus delta r over r. Oops, sorry, you guys can't even see what I'm doing. I'm so sorry. Hey, please let me know. I'm sorry, the cameras are, I don't know, I'm trying to get these two cameras to point correctly for each other, and I don't seem to be doing a very good job of it. Yeah, that's not any better. Sorry. Two cameras don't line up with each other. Okay, any questions? You guys feel like you're not going to be able to get through this? Do you want to keep going with this one and plug the numbers in? Or do you want to set up the next one? Remember, it does not matter whether it's division or multiplication. You're still going to be adding. So that's partially what kind of simplifies things a little bit, because as long as it's only multiplication and division, you're just adding all the fractional uncertainties, just paying special attention to the fact if there is anything that's squared, or let me point out where this is even more powerful. What if it was the square root? What do you do if it's the square root? You put 1/2 in front of there. You put the exponent in front of there. That is what you do, period, even if it's a root. So 1/2, 1/3, 1/4, you put a 1/3, a 1/2, a 1/4 in front of that delta V over V, if that's the case. Okay, so I'm assuming we're going to go on to 12, and this one says density. I'm going to show you a symbol for density, and I'm really showing it to you because I don't know if you've ever seen it before, and it's what you're going to see in the IB book. So, I'm sure that in your class you probably used capital D, but capital D is not what is used generally. It looks like this. So density is equal to mass over volume. Okay, and volume is obviously the length times the width times the height, right? So in this case, the mass is equal to 2.2 plus or minus 0.2. The sides are, so I'm going to do length, width, and height. That is going to be 60 plus or minus 3. Doesn't matter what order. All right. So again, the formula involves nothing but multiplication and division. So we don't really need to think too much. We just need to get all of the components. This is going to be, let me write this again. Density is equal to mass over length times width times height. All right. So the uncertainty in the density is going to be equal to delta M over M plus delta L over L plus delta width over W plus delta H over H. That's it. So you're going to plug in all these 4 uncertainties. They each go into their spot down here in the equation. Go through, crunch those numbers, get that calculation, figure out what it is. It's going to be point something. And then it's really up to you how you want to approach it. I mean, you don't have to do the calculation in here. If you want to just calculate the density, look, the numbers are right there. So you're going to take the mass, 2.2, divided by the quantity, 60 times 50 times 40. So you can just do that in advance if you want to, or you can just do it in here all together. So the whole calculation is being done at once. But that is basically how you would set that up. And I feel like this is a case where, I hope it's fairly obvious to you guys, that's going to be a little more challenging to do with the range method, right? Because you really got to think it through. You have division, so that kind of creates a complication. And then you have all these numbers. So your largest value would be 2.4 divided by 57 times 49 times 38, right? That's just one calculation to get the high number. So I feel like here's a situation where I feel like the formula is easier and faster than using the range method. But the range method would work. The range method would work. So what I would recommend is, this would be a great thing for you to practice. Remember, you don't have to do all the problems in the homework assignments that I'm listing. Take one of these problems, finish it, get the answer by the formula, then do the range method and prove to yourself that you can produce the same answer with the range method. That would be a great way of just verifying that both methods work and that you really understand both of the methods.